Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. We've been spending quite some time implementing enemies the last couple of episodes, so let's turn our attention back to the environment. There are some destructible elements to each level, and in this episode we will focus on the bridges and the shootable bricks. Now the bricks are simple enough. If a bolt hits it, they should be destroyed, and the bridge can be destroyed by walking on it twice. Now this will be the first time we'll add an active tile that actually is solid, so we'll need to figure out a way to handle that. Alright, let's start with the shootable bricks that you can see here. These need to be able to be shot. They're part of the level geometry. They are a solid tile, as you can see here. Now, the problem that we have at the moment with our shooting code is that we can shoot straight through walls that have a single tile. So let's first take a minute to fix our shooting so that the bolts behave properly so that we can start shooting these bricks. Let's go into the bolt class here. And what we're going to do is we're going to just redo this entire update method here because I am not happy with this whatsoever. So let's see, we can keep a few things here. So let's align here with the grid properly. So if we're facing left, then we should do 8, and otherwise we should do 0. And that should be our X, correct column, and not 8, of course, but we need to add in our remainder that we have here, which is probably always going to be 8, since Duke can only move 8 pixels, but let's do this correctly. All right, so let's go ahead and grab the level, state get level, row tile size, column should be X, and then align with the grid properly, and then divide it by the tile size. So if the level is solid at this point here, then we should hit the wall. And let's calculate the spark X position. So let's do int impact X equals X. I guess we'll just do spark X equals X plus facing left. Then we should add 8, and otherwise we should subtract 8 to get the sparks at the right spot. And we should, let's see, spark X. And we should subtract 4 from Y as well to make it look good. And otherwise we need to still check if we are active or not. All right, so this should be decent wall clipping. But what we'll do here is interact with our active tiles. We'll do that first before we update with the level geometry so that we give the active tiles a chance to get hit first. So let's move this guy to his correct position first. So move to X plus our facing is left, then minus tile size, otherwise positive tile size. And then of course keep the Y position. So this will update us to our new position instantly. So that means that inside the Duke class, we need to spawn the bolt at Duke's X, so we don't have to do all of this stuff anymore. So let's go back into the bolt. So the first thing we'll do is we'll move. Then let's keep track if we have hit something. And let's keep track of our actives. So while we have not hit something and our I is less than the level get actives dot size, then let's grab the active tile from the level get actives get I plus plus. Then we've hit something if that active collides with the bolt. And then if this is the case, then we'll tell the active, hey, you're hit, and we'll pass in the game state. All right, so let's go into our active class, superclass, I mean. And let's see, we have a hit method that takes in a game state. So this should be a public hit. And this check hit can go, and we'll replace that with a public boolean can be shot. And by default, actives cannot be shot. So each active has to be explicit about if they can be shot or not. So let's build the project, and now we have a lot of compile errors, so we'll fix that. So this check hit is no longer needed because now the bolts do the hit checking for us. So we can make this public, and this guy can be shot. A box does not need to be updating anymore. And this guy can be shot as well. All right. A camera does not need to do a check hit anymore. And can be shot is true. All right. Wall crawlers, no need to do check hits anymore. Where is our hit? Here. Public can be shot, return true. And then here we have a patrol bot. I don't think these have a hit implementation. So let's just do the can be shot here. All patrol bots can be shot. A tank bot, public hit, and the tech bot should also make this public. And since it extends the patrol bot, we don't need to do. Okay, so all right, so the last thing we need to do is change the order in which we update our entities. And we're going straight through the wall. So that means that we still have an active flag to set. So here when we hit the wall, yeah, that's not implemented at all. So this hit should be a hit wall. Hit wall. And that should set the active to false. Let's fix the order in which we update stuff, because we update Duke last. We should now update Duke first, and then the bolts. And then we'll update the level and do the maintenance of all the effects and spawns. Okay, so this should let the bolts behave properly. All right. Okay, we just need to remove the bolt when we hit something here. But let's first see if we cannot shoot through walls anymore. So this wall is fine. And then let's quickly go to our bricks. It's a long walk. And now when we hit an active, we should also clean up the bolt as well. Okay, we can't shoot through these bricks anymore, so that's good. So let's just keep track of the hit something here. Private boolean hit something. Default it to false. And then let's say that if we hit something, then let's flag this guy to be removed. Else we'll do our update code. All right. This should totally fix our bolt to properly behave. And looks like it does. It stops. All right. Now, so active collides with this, hit something. This can go away. Okay, so let's create our bricks. So our bricks will be an associated active class. Now the bricks are tile 1800, which are considered part of the solid level geometry. That's why the bricks that are in place now, they actually block movement, so that is great. So all we have to do here is say that these guys can be shot. And then if they're hit, we need to increase our score by 10 points. We need to add some effects. So let's spark it up and let's add a smoke. And most importantly, we need to replace the brick ID, brick tile with a new one. So let's go ahead and calculate our row and column, and let's replace us with the background brick. So let's figure out what are the background bricks. So let's read our tiles and let's save them. All right, of course, so we need to create this method here. So let's first start with tile 0, I suppose. We'll figure this out in just a second. So set tile, row, column, and then tile ID, and then we'll just do tiles row times level width plus col equals tile ID. And then let's try again, printing out our tiles. Okay, let's find our bricks. So here are our bricks. So if this is tile 1800 and these are the background bricks, then that means that's 1800 minus 32, but it's hex, of course. So let's open the calculator. So hex 32 is 20, so we need to subtract 20 from this. So the background bricks are 17E0. So let's replace this with 17E0. And then all we have to do is add these bricks to the resource loader. So let's go ahead where we read in the level. And then for now, we'll just add some extra if-else switches here, and we'll fix this level loading code when I'm tired of it. So this should take in the actives, add in new bricks, and we need this X and Y thing here. X, Y, and then we can say else if. All right, so this will add the bricks to our level, and yeah, I think they should be shootable now. So let's see. And let's run to our bricks real quick. Should update our speed to 16 instead of 8 pixels, I guess. So let's run to the bricks. Bricks, where are you? All right. So that destroys one brick. And that keeps, okay, so our set tile isn't. All right, we need to, of course, let the bricks remove themselves when they're shot. So we should set active to false here. So this should clean up the bricks after they're shot. All right, so that is the bricks. So let's go ahead and add the bridge as well. So I already highlight here the location of the bridge in the level. So that's 3019. So let's just go ahead and add a new class called bridge. We'll extend active here as well. And let's create a new constructor, public. Now the bridge has an amount of columns that it spans. So let's say columns times the tile size -1. All right, so let's walk over to the bridge in the game, or where it's supposed to be at least, because it's not there yet, of course. So the point is that this tile here that you can see is supposed to be a bridge that is solid for these enemies to walk over it, and it needs to fill in this entire gap. So what we need to do is adjust the level loading code to fill in this gap with solid tiles that represent the bridge. So what we should do is we should go to our resource loader, and I guess we've printed out the tiles here. So let's go to our solid tiles and locate our bridge tile, which is located here. Now, if you were to count the tile IDs and try to find them at the, try to find the correct tile ID for these bridge, you would start at 1800 here and then just add 20 hex until you reach the bridge. And if you do that, you will end up with a value called static final int bridge solid tile ID, and that is 21A0. So what we're going to do is we're going to load up the level, and we're going to replace all the tiles to fill up the gap with the solid tile IDs for the bridge, because these tiles here are considered solid tiles, so that means that enemies and everything Duke will also collide properly with this tile here. So how we do that, let's go into the bridge class and let's just create a static method here, public static bridge, that says create the bridge. We'll have the location where the bridge is at in the level, and we need all the tile, then we need the tile array basically. So let us keep track of the columns. So int columns is 0. Let us keep track if the bridge is closed, and then we'll just say, well, the bridge isn't closed and the width of the bridge does not exceed the level. So in theory this should never happen if the level design is good, which it is of course. So first what we'll do is we'll override the tiles with the solid tile ID. Now as you can see, there are two tiles that represent the bridge, 1 and 2, for some alternating graphics. So what we need to do here is we need to add in columns mod2. So every odd column we go to the next tile, and we do that by multiplying by 32. And then increment columns, and then we'll say closed is level is a solid location plus columns. And then when that is all done, we need to know the X location for the bridge. So that's the original location modded by the level width multiplied by the tile size, and then the Y is divided by the width. And then we'll return a new bridge, X, Y, columns. So we're just missing the solid static method, so let's make that here. Public static boolean is a solid for a specific tile ID. That is this check here, and then return is solid tile ID. And then let's inline this. So now the bridge knows whether or not it reached a solid tile. So, and now all we have to do is let's override our update method here so the bridge won't fall down. And now in the level loading code, we need to create the bridge. So let's go to our resource loader and let's just add another if statement here. So let's go to the browser. I already highlighted the bridge tile ID. So this is the level format with all the active tiles. Here it says tile 3019 is bridge that explodes when stepped on twice. So 3019, else if tile ID equals 3019 bridge, then we'll say actives.add bridge.create I tiles. And then we need to take care that these tiles, because if we have this if statement here and then it overrides blindly the tile with whatever it read, the bridge will break. So we need to put this here, and then we need to put this here, tiles I equals the left tile. Okay, so this should in theory add a solid bridge for us and our enemies to walk on. All right, so we only have the first one. So let's see, what did we do wrong here in this create method? Oh, right, of course, I have to fetch the tile ID, tiles. Otherwise, it will do the is solid check, comparing it to a wrong number. So now it should actually check. All right, so now we have a solid bridge. So you could see that this guy can actually move across the bridge. So that just leaves us with destroying the bridge when we touch it twice. So in order to do that, we start implementing our update method. So let's take Duke. And then we can say like, okay, if Duke is on top of the bridge, then we'll register a hit, I suppose, kind of like it's been shot. So let's make a on top method first, private boolean on top Duke. So when is Duke on top of the bridge? Well, first, of course, his Y location needs to be aligning with the bridge Y. So let's take in Duke's Y, let's add Duke's height, and let's add 1, because we subtract 1 from the height. So return this Y should be exactly our Y. That means Duke is exactly on top of us. And then all we have to do is check the X positions to know that we're within our bounds as well. So let's take Duke X. So Duke X should be greater than or equal to our X. And the Duke X plus Duke width should be less than or equal to our X plus our width. All right. So if Duke is on top, then we hit. And let's implement hit. Let's decrease some health. So a bridge has 2 health because it can be hit twice. So health equals 2. And let's do a check here. If health equals exactly 0, then we need to replace the bridge with like background tiles so that we can fall through them. So let's calculate the column for the bridge. So that's X divided by tile size. Column should be less than or equal to the X plus our width divided by the tile size. Call plus plus. All right, and then we can say that our tile, so let's grab the level. I guess I can just do state, get level, set tile, and then the row should be, I guess we'll just calculate the row here, Y divided by tile size. So we have row, we have call, and I guess we should just copy over. So I guess we level state get level, and then here we can say level set tile row column is level get tile row -1 column. So we'll just copy the tiles that are above the bridge, and then we'll remove the bridge. All right, so now each time we're on top, we're reducing the health, and we only have 2 health, so I expect this bridge to like instantly be destroyed when I stand on top of it. Yep. So that's pretty cool. So what we need to do is make sure that Duke needs to exit the bridge first before we start decreasing health again. So how we do that is, I think we'll just keep track with a boolean, private boolean on top. And then if Duke is on top, he should not be already on top. So if not on top, then we'll do the hit. And then here we'll just keep track on top is on top Duke. And then I guess, yeah, we'll just do that here. So this means that while Duke is on top, we only decrease the health by 1. until Duke first leaves. Okay, and let's see if the gravity for these tech bots work as well. So let's go. Yeah. So we can destroy the bridge. These tech bots will fall down. So that's pretty cool. This guy is spacking out. Let's kill him. All right, so now we just need to add some effects for the bridge when it's destroyed. And yeah, I think that will just about do it. So let's see, when a bridge gets destroyed, we need to, of course, add some sparks and some particles, I think. So what we'll do is we will check if the, so every odd column, I guess. So let's calculate our base call is x divided by tile size. And then let's do for int I equals 0. And then we can say that I should be less than I plus width divided by tile size, and then I plus plus. And then we can do call plus I, call plus I. And then here what we can do, if I is odd, then we'll add an effect, sparks. And what we'll do is we will do x plus I times the tile size y. Okay, so why is this sparks int int? All right, like this and this. And we need to add some particles. So I guess we'll just assign this to, I don't know, effect X or something. So we got effect X, and then we'll offset these by the tile size. All right, so this should spark up the bridge. Not sure if destroying a bridge gives points. Oh, we have a lot of points wrapping up to do anyway. All these items still give the wrong amount of points, so let's check that later. So that's one. Let's walk off and let's walk on it again. All right, so I guess I messed up a bit here. So what did I do wrong? I guess I should just do I is less than, I suppose. But I thought that because I do the width -1 thing. Okay. So that works just fine. So that destroys the bridge. So some nice particle effects. So I think that about wraps it up. You know, we've added a destructible bridge. We fixed our bolt again for the second time. So I hope this was the last time we had to fix it. It's looking way proper now at least. And we have some destructible bricks here. So yeah, going down here, we're supposed to have an elevator here. So I think that is what we'll do next episode. We'll implement the elevator going up. There are 2 here in this level. So once we've done that, I think we're getting near to a complete level. We just need to add a few more enemies and a couple of more items. So yeah, I hope you can join me for next episode where we will implement the elevator. If you have any questions, put them down in the comments below, and I'll see you guys in the next one. Cheers.